Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Command line networking tools are essential for diagnosing and fixing connectivity issues. These tools give technicians real-time insight into how a device communicates on the network and across the Internet, whether testing a local connection, verifying a device's IP address, or checking for Internet access. These utilities are foundational to any network troubleshooting process. The A+ Core 2 certification emphasizes the correct usage of these tools, along with interpretation of their output and the logical steps needed to isolate problems. One of the most commonly used tools is ipconfig. This command displays key information about the system's network configuration. It shows the current IP address, subnet mask, and default gateway. It also includes domain name system settings and dynamic host configuration protocol status. Technicians use ipconfig to verify that a system has a valid address and that it is connected to the correct network. It's often the very first step in identifying why a device cannot reach other systems or services. ipconfig has several important switches that enhance its functionality. Typing ipconfig with /all shows the full adapter configuration, including MAC addresses, lease times, and whether the address was assigned by a DHCP server. Using /release tells the system to drop its current IP lease, while /renew requests a new lease from the DHCP server. These commands are useful when troubleshooting connectivity issues after hardware changes or when moving a laptop between networks. This command is especially helpful when identifying problems with local IP addressing. If the system shows an address beginning with 169.254, that is an automatic private IP address, meaning the system failed to reach the DHCP server. If no IP address is shown at all, or if the adapter is listed as disconnected, the issue may be hardware-related. ipconfig helps confirm whether the system is configured dynamically or statically, and whether its current settings make sense for the environment. The png command tests whether a target device is reachable by sending echo requests using the ICMP protocol. When the target responds, the system displays the round-trip time in milliseconds. If the response never arrives, ping will show errors such as request timed out or destination host unreachable. This makes it a simple and effective tool for testing basic network connectivity. It also helps confirm whether a problem is related to local configuration, routing, or even firewall interference. Interpreting the results of a ping command gives you valuable feedback on the state of the connection. When a reply is received, the output includes the time it took for the message to make the round trip. That time should be low on local networks and may increase with distant hosts. If no reply is received, then something is blocking the communication. The -T option sends continuous pings, which are helpful for monitoring intermittent issues. The -N flag allows you to send a specific number of ping requests. Technicians use ping in stages to test different parts of the network path. Pinging the loopback address 127.0.0.1 verifies that the network adapter is functioning. Pinging the gateway confirms whether the device can reach its local network. Pinging a known public IP address like 8.8.8.8 tests basic Internet connectivity. If all these steps succeed, then the network path is intact, and the issue likely lies with name resolution or application behavior. Another important tool is spelled tracert, but pronounced traceroute. Traceroute shows each hop a packet takes to reach its destination. It provides timing information at each step, helping identify where a delay or failure occurs. This is particularly helpful when troubleshooting slow or failed connections that go beyond the local area network. If traceroute fails after several hops, it often means there's a routing or internet service provider problem. These results help determine whether escalation is needed. Traceroute and ping serve different but complementary purposes. ping tells you whether a device can be reached, and traceroute shows how it is reached. While traceroute takes longer to run, it maps out the exact path your traffic takes and highlights where things go wrong. These tools work best when used together. On the exam, you may see a scenario where you must identify which tool to use or read output from both to find the point of failure. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Another useful tool for network diagnostics is NSLookup. This command queries domain name system servers to resolve domain names into IP addresses. You can use it to test whether a DNS server is functioning or whether a specific domain is resolving correctly. NSLookup is especially helpful when pinging an IP address succeeds, but domain-based requests fail. It can also test alternate DNS servers by specifying their address in the query. Netstat is used to display active network connections, listening ports, and various network statistics. Running Netstat without any options shows open connections and their associated local and foreign addresses. You can also see which ports the system is actively listening on, which is useful when troubleshooting firewall issues or checking for suspicious activity. Administrators often use Netstat to detect malware, unwanted services, or failed application bindings. The command ARP with the -A switch displays the Address Resolution Protocol cache. This shows a list of known IP addresses and their associated MAC addresses. The ARP cache can help detect duplicate IP assignments, spoofing attempts, or other address conflicts within a subnet. Technicians may clear or inspect the ARP table during troubleshooting when devices appear to be reachable but are responding incorrectly. NBTstat is a command used to resolve NetBIOS names to IP addresses within local networks. Although it is considered a legacy tool, it still appears in small or older environments that rely on server message block or SMB for file sharing. NBTstat can display name tables, active sessions, and other connection-related information. It is especially useful when name resolution problems occur in non-DNS-based local setups. PathPing combines the functionality of ping and traceroute into a single tool. It maps out the path to a destination and measures the latency and packet loss at each hop. While it takes longer to run than traceroute, the output includes more detailed diagnostics. PathPing is most useful in identifying intermittent problems or pinpointing specific routers where loss is occurring. It may not be used as frequently in quick tests, but when needed, it provides a full picture of the issue. Two additional commands to know are netuse and netview. Netuse maps drives and printers to shared network locations using universal naming convention paths. For example, mapping a drive to /server/share. Netview shows available network devices, allowing technicians to confirm whether a shared resource is accessible. Both commands are useful when troubleshooting file sharing or verifying whether a user can reach a network folder or printer. Output from these command line tools can be redirected to files for documentation or review. Using the greater than symbol saves the output to a new file, while the double greater than symbol appends it to an existing one. This is useful for creating log records or capturing results during a scheduled script. Automating tasks like pinging a gateway or checking for route changes can help detect patterns over time and are often used in long-term troubleshooting workflows. A typical network troubleshooting workflow might start with ipconfig/all to verify network adapter settings. If the device has an expected IP address and gateway, the next step is to ping the gateway. If that succeeds, you can use traceroute to check the path to a destination. If the destination is reached, but domain names are not resolving, NSLookup can confirm whether DNS is the problem. These steps help isolate whether the issue is local, network-based, or related to name resolution. Many of these tools have equivalents in Linux or Mac OS. For example, ipconfig is replaced by ifconfig or ipA in Linux. ping, traceroute, and netstat are also available but may use slightly different syntax. Understanding these platform-specific differences helps technicians support mixed environments. The exam focuses primarily on Windows tools, but familiarity with cross-platform equivalents may appear in some questions or job scenarios. To summarize, command-line networking tools like ipconfig, ping, and traceroute form the foundation of network troubleshooting. Each tool provides a different piece of the diagnostic puzzle, whether it's confirming configuration, testing reachability, or mapping packet paths. The A+ certification tests not only your ability to recall these tools, but also your skill in interpreting their output and applying them in the correct sequence. Mastery of these tools is essential for effective support in real-world environments. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.